Hi, you guys. Miss All Day. How are you guys doing? All right, so I'm pulling up first the pacing guide for this week. Okay, so you see that on May the 4th, which was Monday, that you do your test. All right, and so now we're going to do 8-4. We're going to do day 1. It's 8-4A, and there's only a front sheet. Okay, so it's going to be a pretty short one. Okay, rational expressions. So remember that rational expressions are, the root word is ratio, which means a fraction, right? Okay, so don't these look like fractions? Okay, a rational expression is in simplest form when its numerator and its denominator are polynomials that have no common factors. So basically you've reduced it, okay? You've simplified it. To simplify, you must factor the numerator and the denominator completely. A rational expression in any simplified form must have the same domain in order to be equivalent. All right, so let's go ahead and start with this first one. We have 3x squared over 9x, and we are going to divide both the numerator and the denominator by 3. Really, you're just reducing it, so you could really just go like this. 3 goes into 3 once, and 3 goes into 9 3 times, whatever way you want to do it. There's a 1 now in the numerator, and there's a 3 in the denominator. Now, remember when you are reducing and you have x squared divided by x. What that really is that's x to the 2 minus 1. Remember when you're dividing that you end up subtracting the exponents. So 2 minus 1 is x. Another way to look at it, if you forget why that works, you have 2 x's on top and 1 x on bottom, and so you're canceling 2 of them. All right, so when you do that 2 minus 1, your answer goes in the numerator. So that's 1x. I'm going to erase the 1 because we don't need it. And so our answer is x over 3. But there's one thing we have to do. In order for this to be a rational expression and for us to know what the domain is, we have to look at the denominator and say, that cannot be 0. So if you set 9x equal to 0, because you don't want it to be 0, and you divide it by 9, you find out that x cannot be 0. So that's finding out what are the parameters of your domain. It says here, a rational expression in any simplified form must have the same domain in order to be equivalent. So we know that x cannot be 0. That's the restriction. That's the restricted value. If you look right here, it says, determine if the rational expression is in simplified form. Well, this one wasn't. So if it's not, simplify it. So we did that. And then it says state any restricted values. All right, so I'm going to go and put this back just so you see my work. And I'm going to go put x is not equal to 0. And we're going to call this a restricted value. All right, let's go ahead and look at the next one. We're going to divide both the numerator and the denominator by 6. Now, when I cross out this 6 down here, it still means that there's a negative there. I haven't gotten rid of the negative. So 6 goes into 6 one time. You can put it there. You cannot put it there. And 6 goes into 24 4 times. All right, now we have 4 in the numerator. So we're going to do h to the third minus h squared. So that's going to be h to the 3 minus 2. And then we have j to the second, negative 2, minus the j to the third, which is negative 3. When you say minus 3, that becomes a negative. All right, so you have 4h, because 3 minus 2 is 1. And then j to the negative 2 plus negative 3 makes that j to the negative 5. And we know we have to bring the j to the negative 5 down into the numerator to turn that negative to a positive. So it is no longer in the numerator anymore. It comes down to the denominator. All right, now the next thing we have to do is we have to go back and we're going to look at the original problem and we're going to see what are the restricted values. So you want to say that h squared cannot be equal to 0. So that basically means that h cannot be 0. And if you set j cubed equal to 0, you would find out that j cannot be 0. So we're just going to go ahead and say that h and j cannot be 0. All right, so this is our answer, and this is our restriction right here in pink. All right, so for this first one, you could actually go ahead and do your restriction first if you want to. Take your x minus 3 and set it equal to 0 and put not. That means x cannot be 3. That's our restriction. All right, so if we're going to go ahead and work the problem, we're going to cancel these, and your answer is 3. So your answer is 3, but your restriction is x cannot be equal to 3. Because if x was equal to 3, then your denominator would be 0, and that answer would not be true. All right, for this next one, there's nothing that I can do to reduce it or to simplify it. So I'm going to put that it is already simplified. Now you look in the denominator and you don't see any x values, right? Then you don't have to put any restrictions on this. So this actually is the answer because it's already simplified. Now, we know that if we set this equal to 0, that x would be 1. And if we set this one equal to 0, that x would be negative 2. Those are the two things we don't want x to be. So that's considered the restrictions. All right, so we're going to cancel these, and your answer ends up being x minus 3 over x minus 1. You could leave it like that, or you can put the parentheses around it, but you don't have to if you don't want to. Just know that the x minus 3 is connected, and the x minus 1 is connected, so you cannot do this with it. You cannot, like, just, boom, get rid of the x like that. You cannot do that. So sometimes it helps to put them in parentheses to realize that you can't really do anything with them. All right, this last one. Now remember up above it had mentioned that you were going to have to factor the numerator and the denominator completely. We haven't had to do that yet. We're going to have to do that now for f. So if you look at 4d squared minus 10, you know that they both have a 2 in common. So 2 parentheses 2d squared minus 5. So remember, 2 times 2d squared is 4d squared, and 2 times negative 5 is negative 10. So that's how I factored it. I pulled out the GCF, which was 2. All right, we can't factor the numerator anymore, but we see in the denominator there's a d, and if we set 2d equal to 0, then d is going to be 0, and that's what we don't want it to be, because we do not want the denominator to be a 0. So that's the restriction. Now we're going to go ahead and do a little bit of canceling. We can cancel the 2 and the 2, and then that's it. So you can write 2d squared minus 5 over d. If you want to keep it in parentheses so you don't try to cancel something, you can, but you don't have to. This time I won't. That way you know it's okay if you don't, as long as you don't try to cancel anything. All right, let's move down to G. If you look at this one, you're like, I can't do anything else to it. You're right. So this really is the answer. It is already simplified, but you do have to tell me what the restrictions are. All right, so the restriction is that x cannot be negative 3, because if x was negative 3, that would make the denominator 0, and that wouldn't be a number. Anything over 0 doesn't make sense. You can't have something out of nothing. All right, let's look at the second one in this row, h. We're going to factor. So you got to remember a little bit about factoring. So let's look at the first one. You want to think of two numbers that when multiplied give you 10, and that when added or subtracted give you 7. All right, so we know we're going to have an x and a 5 and a 2. And since they're both plus signs, these are both plus signs. All right, so that was pretty easy. Let's look at the bottom one. Two numbers that when multiplied give you 10, but when combined give you -3. So x and 5 and 2. And they both have minus signs. Okay, so that means you're going to have one that's a minus sign and one that's a plus sign. All right, now you want your minus sign to be in front of your number that's larger, because if it wasn't, and it was x minus 2 times x plus 5, when you did FOIL, x times x, x squared, outer is 5x, inner is -2x, and last is -10, you see that 5x minus 2x will give you a +3, and this is not a +3. So that's just FOIL, just to help you remember, because we haven't really done much with that recently as far as factoring. All right, so let's go ahead and see what our restrictions are. We know x cannot be a -2, and it cannot be a +5. All right, so now we're going to cancel, and our answer is x plus 5 over x minus 5. I'm going to put parentheses around them, but remember, you don't have to, as long as you know they can't be canceled. All right, let's go to J. Let's look at the first one. Now, if you look at this, you might think, if I was going to factor it using complex numbers, that is possible. But you wouldn't be able to reduce it if it was complex numbers. So we're just going to leave it as is, because we're not doing complex numbers for this part of this lesson. Okay, so this is already simplified. Now we just have to pretty much say, what can x not be? What is the restricted value for x? So I can see that x cannot be -2. All right, our last row. All right, so we're going to go ahead and factor the bottom, because the numerator is going to stay as is. What's the GCF for both of these? 3m is correct. So 3 times what is 9? 3. And m times what is m squared? M. And then 3 times what is 4? I'm sorry, 3 times what is 12? It's 4. All right, so I don't like how my line looks, so I'm going to fix it real quick. Boom. All right, let's go ahead and figure out what our restricted values are. You can set 3m equal to 0 if you want to, but I know that m cannot be 0, because if m was 0, then that would disappear, and it would make that next to it disappear if I multiplied it. All right, you might want to set 3m plus 4 equal to 0, but remember, we don't want it to equal 0. When we subtract 4, we get 3m equals -4, and we're going to divide by 3. So we see here that m cannot be -4/3, and it cannot be 0. All right, now we can cancel. Cancel those. Now remember, when you cancel that on the top, there's always a 1 up there, because you have to be able to go back and look at it and say, how could I get this 3m? Well, if I multiplied 1 times 3m, I'm going to get 3m. So when you cancel, it's just like if you had 2 fourths and you said 2 goes into 2 once and 2 goes into 4 twice. You still have a 1 in the numerator. All right, so your answer for this is 1 over 3m plus 4. You can leave parentheses there, or you cannot. Just remember your restrictions. All right, for this next one, you want to turn this around. You want to make it -4c plus 12, and then c squared minus 9. We're just going to leave it like that for now. All right, let's pull out a -4, and that's going to be -3 plus c. And really, I guess you could have kept it the way it was, and it would have worked just as well. I'm going to show you something in just a minute. All right, we're going to do c squared minus 9. We're going to factor it into c plus 3 and c minus 3, because we know that we have ax plus bx plus c in a quadratic equation, and we see that there's an ax squared, and we see that there's a c, but there is no bx. So we know that that part has to cancel out. All right, so what I'm going to do right here is I'm going to switch those back around because really, I didn't really have to do it this way. I could have pulled out the -4 here and said that that would have been, what, -4 times 3, -3. Okay, it would have looked the same, wouldn't it? All right, so I'm going to leave it the way I did and do -4c. I don't know why. -4c plus 12. When I did the -4, I switched these for some reason. I don't know why I did that, but I did. So I'm going to fix it. -4 times c, and then -4 times -3. Okay, that looks right now. All right, so now we recognize that we can cancel too. But before we do, let's go ahead and figure out our restrictions. Our restrictions is c cannot be 3 or -3 because that would make our denominator 0. So we can cancel those out, and our answer is -4 over c plus 3. I won't put the parentheses this time, so you know it's okay not to do. All right, last one. We're going to turn this whole thing around and make it -x squared minus 3x plus 10. And we're going to go ahead and pull out the negative first. -x squared plus 3x minus 10. You don't ever want to have a negative where your x squared is. Always pull that out. All right, we're going to go ahead and factor the denominator, x and x. So what two numbers when multiplied give you 2? Well, that's going to be 2 and 1. That's the only thing that works. But when combined, give you a -1. So we know the bigger one has to be negative when our b in our x squared plus bx plus c is going to be negative. Our bigger number has to be negative. All right, now we're going to factor the numerator. So negative times, I'm going to go ahead and rewrite my denominator, x minus 2 times x plus 1. We have x and x. We know it's going to be 5 and 2 again. Since our b is positive, our bigger number will be positive and our smaller number will be negative. All right, so next we are going to go ahead and figure out what our restrictions are. We know that x cannot be 2 and it cannot be -1. And then we see that that can be canceled. And we have -x plus 5. You have to keep the parentheses for the numerator. You don't really have to keep it for the denominator if you don't want to. So that's our final answer. All right, let's jump back to our homework assignment. So we just did 8-4. We did rational expressions. We just simplified them. Your homework is page 530 to 531. Problems 1, 7 through 13, odds, and 27 and 29. And then after you do that, check your homework in the back of the book. Make sure your answers match up. That way you make sure that you did it correctly. You don't want to ever learn something the wrong way. All right. See you tomorrow, you guys. Bye.